Hey guys, welcome to, what is this, week 4 here? Week 4 or 5. Finally going to get to assembly of the PCB and doing the firmware also. So right now I've been, getting started a little late. I've been looking at the firmware, trying to get some stuff sorted out on that. So I'm going to flip back to that and show you what I'm working on. And then we'll get to the PCB assembly here in just a moment. So what I'm trying to do here is, if I can get the right thing enabled here. There we go. So I'm looking at the firmware definition for this PCB, trying to do the mapping from, this is what the layout looks like logically. Here's the physical matrix. Trying to get this set up. Right now it's telling me I have 70 keys down, 70 entries here, and over in my key map I only have 64. So I'm trying to figure out why that is. Because I don't always see when I'm missing something. So if you just see it right offhand in chat, just let me know. I'm going to be looking down over here. I've got the other monitor with the key map definition from KiCAD on it. Let's try the matrix definition. I'll show you what I'm looking at here. Looks like that. This is what we worked on in the very first week. So I should have 64 switches. That's what I'm showing here. So my key map is correct. So the problem is in my key definition here. So here's the question: is what's defined over there that's not defined over here? Oh, it's because they all start with 0. I've got too many. Oh, just one too many columns. See, that's easy. Easy enough. That means off here. Oh yeah. So I've got them numbered by starting with column 1 here and starting with column 0 in the other one. It's always a bad idea, right? So I need 45. So I got, oh, let's see, this is even more off. So 6, 7, 8. Oh, never mind. Sorry, these are numbered. So this is, oh, it is. It's column 1, column 2. We skip column 3. That'll be confusing if I do that. Skip column 3. We've got this hooked up to column 4, then we skip column 5, and we have one hooked up to column 6. Then we skip 7, and we have 8 and 9, which are going to be labeled as 6 and 7 on here. 6, 7, I'm sorry, 7 and 8. to skip column 10, which should be KC49. And this will be A, B, C. And then we don't have column E. Probably would have been easier to actually go in and do this as a actually go in and take those numbers out. Let's see. Go renumber these, but that's right. Change it. Okay, so this should be on 11, 12, and 13. Yeah, I don't have 14. Still not matching. What am I missing? I'm streaming to myself at this point, but if anybody's watching this later on the video on demand, then good. Pull up another one and see if I'm doing something really odd. Yeah, we got extra something up here. Let's see what it is. I should have 1, 2, 4. 2, 4, 6. There it is. Okay. There we go. Okay, so got the code compiled. We're going to flip over and we're going to start working on the PCB assembly. So for that, I'm going to pull up KiCAD here. I'm going to be referencing that, and then I'm going to pull up my little camera here. Apologize, let me get this fixed up real quick. So, see what we got here. Get it a little bit in focus. I'm just going to slide down this way. There we go. You can kind of see what we got going on here. Alright, so we got the PCB that designed the first week, had shipped off, manufactured, and it is back. I have one component on the top side, which is the reset switch, and I'll do that later. On the bottom side, I've got most of the components, most of which are the sockets. So I'm gonna apply the first step is gonna be to apply the solder paste using the template. But what I wanted to do first was check the fit of these little PCB sockets that are going in here. And when I did that, I found that they're a very tight fit. And I was going to check if I can figure out where I put my calipers. Well, no, they're not in here. I left them in the garage. So I was going to check and see whether that was the fault of the PCB manufacturer, or if the sockets themselves were out of spec, or if I drew the footprint wrong. These are just really hard to get in here into these sockets, so that's going to become a problem when we start trying to do this with solder paste. And obviously, if we sent this off for pick and place assembly, the robot's not going to have that much force to push down in there. So we do need to identify, before this can go to manufacturer, what the problem with that is. For now, all we really have to do is just make it work. And gosh, that's tight. Since I can't even get them in and out of there without causing problems, I'm going to need to find me a file and do some work on this. Got some stuff here in my drawer of junk. Got some tools. One of these is a round file. Not that one. There's the winner. Okay. And also a flathead screwdriver for prying this thing loose since it doesn't fit. So this can take me just a minute to go through and do all this. Again, this is not something I should have to do if I got everything designed correctly and everything is to spec. So I will be going back and trying to identify what the issue is. In the meantime, I just want to make it work. It's still tight. I'd had some of these done a few weeks ago using the same footprint, same manufacturer, and they were a little tight. They were not this tight. I could get them in with just a little bit of force. This is like, I can't even get it in no matter how much force I use. About to go get a hammer. So this is going to take a little more filing. I was hoping it'd just be a little bitty bit, but this could take a while. There are 128 of these holes. Ow, that's sharp. Maybe do it like that. think sometimes the manufacturers only have certain drill sizes. So if you specify a drill size, they're going to pick the one that's closest. They have a lot, but maybe they don't have this particular size. Or maybe their drill's out of spec. I don't know. Maybe I just drew the hole the wrong size. I've used this footprint before with another manufacturer, and I don't think I made any changes to it. And it was no problem. I've even had PCBs assembled and didn't have any report that there was a problem with the pick and place. So I think it's just this manufacturer. Okay, they're going in there now. So only you know, like 70 more of these things to go. Not 70, but you get the idea. I guess. I've done 4. 60 more to go. Not your normal part of PCB assembly here, of course. We will definitely get to PCB assembly at some point, but at the moment, you just got a lot of prep work. So I never claimed that this was going to be the prettiest 5-week build, but I'm still on track to get it finished by next week. I've got some acrylic parts being made for the top plate, of course by Joe Limon and Jordy over at Strata Keyboard. He's always great when I need something done out of acrylic. He can get it done quickly. And I've also got a local manufacturer here in town looking possibly going to have some either, well, I don't know. We'll see what they end up with. Maybe stainless steel or brass or aluminum. I don't know, maybe they'll just give me something cut out of steel if they have it. I told them if they had something in stock, they could get it done by the end of this week so I could have it next week. We'll see what happens. Now I'm not going to go through and test fit every one of these holes and then take the socket back out and then put the solder paste on, so I'm just going to hope that I do a good enough job on this part right here that it'll just work. There's a reason I like ortho boards. Let's split, playing. They've got 48 switches. So if I had to do this, I don't have to do it 96 times instead of 128. Hands cramping. I've got some alcohol and wipes here. I'm going to give this thing a good cleaning down when I get done with this step, just to make sure that it's all good. I don't want to get any fiberglass dust in there, keeping from getting a good solder joint. So. The rest of these boards I may end up chucking in the CNC with a little bit to do this job for me. We'll see. See how accurate I could get it. Last one. Okay. Ah. That was not fun. Oh, look at that. Giant pile of fiberglass dust on my desk mat here. I'll leave the alcohol in the other room. Figures. Next best thing. Canned air. Probably not the best for air quality in the room, but nice and clean. Let me give this another shot here. Okay. Okay. Now that the boring part's done, on to the next boring part. Okay, so we plop this guy down here. Grab our stencil that I conveniently left across the room under some other stuff. Ta-da! So this is what you get from the manufacturer. Nice laser cut stencil in an aluminum frame. And it's coated in this plastic, which obviously you have to remove both sides of. I believe one time I was using a stencil, I only took the plastic off one side. So when I put the solder paste on, it didn't come out the other side. Oh, that's filthy. Okay, I am going to have to go get the alcohol. Get all this sticky residue off. Goodness. I didn't pull this off right when it came in, and now I'm wishing I would have, because I've never had this problem with it being so sticky before. I think maybe sitting there an extra almost a week. I think this came in Wednesday last week. Okay. So that will plop down on top of there. I will be right back with some alcohol to clean this up. Okay, back with the requisite supplies. Some alcohol, some paper towels. Get this thing cleaned up and start some PCB assembly. I'm going to need this when it comes to cleaning up after the solder paste is. Whoa, there's alcohol everywhere. It's alright, I was about to clean that anyway. Ah, that's got a lot of sticky residue. Didn't want to come off. Gave it a nice alcohol bath. Shouldn't cause any problems. It's just a mess to clean up. Okay, but cleaned everything up from that dust that we had everywhere earlier. So we're good. Okay, put that on here. Making sure we orient it correctly. I need to get all this stuff out of the way because this template is fairly large. I'm going to be using a putty knife. Just a little metal putty knife I picked up at Home Depot, I think. Collect up all these things. Get rid of this file. Okay, I'll set these over here. Okay, make sure I got some room. See which way this is oriented. Appears to go this way, just like I have it. Okay. So when you're ordering this stencil, you have the option of getting one with a frame or without a frame. And after using both, I can definitely say that you're best to get the one with the frame. It's definitely helpful in terms of orienting things and making it all stay in place. You don't have the frame, that frameless one is kind of hard to work with. And when you put it on the shelf and you're digging around for something later, it will slice your finger open if you're not careful, because it is just a very thin sheet of stainless steel with sharp corners. Okay, just making sure everything is aligned here before I start putting some solder paste on here. So just some low temp lead free solder paste. What I typically will do is squeeze a bunch of this out. See if I can get it here where you can see it. Squeeze a bunch of this out onto the putty knife. I'm going to need quite a bit for this thing. That's one thing about these sockets, is that they will suck up a lot of solder paste. So just got me a pretty good goop of it on there, as you can see, and then I'm just going to get to spreading it out. Making sure I fill in all the holes, scrape away the excess. If I had a bigger putty knife, I suppose this could go faster, but I think it'd be harder to control it, so let's see, I'm going to spread a bunch of it out and scrape it up. It's just a matter of going over the whole board. And over here is where all the controller components are, and I want to just check it again real quick to make sure it's all still aligned properly, and then be extra sure to make sure I get everything filled in over here. USB port. Right here, I got a few up here that didn't get filled in. I'm about out of paste here, but I think this is going to get me through. Got a big clump over here. Eyes are going to kind of playing tricks on me with this reflection. Okay, I'm going to wipe off the excess here. I left some on there last time I was working and it was not fun to get off, so I'm just going to make sure I don't do that again. Alright, now when you're taking this off, the trick is just to make sure you don't smear anything. Usually put like a finger here in the middle and then pop that board loose. It's not working right. A lot of times I'll tape the PCB down, which is what I should have done here. And then do a quick wipe down of the stencil to get any excess solder paste off. Still have that adhesive residue everywhere, just making this a royal pain. Have to go back over it later. Set that aside, do a quick check here. Make sure everything looks good. Don't have anything too far outside the lines. For the most part, a little bit outside the lines is not a big deal, but I don't want it too far out. Looks good. Okay. So, I'm going to start working with these sockets just because I know they're going to take some force to get in, and I don't want to have to disturb my other components. So I'm going to do these, then I'll put the controller on, and all the diodes, RGB LEDs, capacitors, USB port, all that fun stuff. Oops, I just smeared one there. I'll have to make sure and come back and fix that. So I need to make sure I get these things snapped in all the way, because otherwise they're not going to sit flat, they're not going to solder right, and they're likely to pop off. So I know some people have had boards, some of the first boards that came out with these sockets, I think it was the XD75RE, had some problems with them popping off. I think that's going to kind of depend on a few factors. Maybe flex in the PCB would cause that to come loose, a bad solder joint in the first place, how tight they made the holes perhaps, how flush they got them onto the board when they did them, lots of things like that. Hopefully I haven't had any problems with any of the ones I've done so far, but I haven't done a whole lot with big boards like this either. These sockets are actually just about as easy to solder by hand as a regular switch is, so that is an option. If you have them come loose, you can just pop one on there and solder it in place. Still easier to reflow it. Takes less time since I have to reflow the other stuff anyway, so I don't bother with trying to solder these by hand. Just when I hit one that comes a little bit hard to snap in there, I'm just hitting it with these backside of these tweezers to make sure it's down all the way. About that, I grabbed the exact right number out. $100 for me. Okay. Next up, we got some diodes. This is kind of the not fun, tedious part. Because the other components are small, but there's not very many of them. The diodes, 64 of them, just like there are the switches. So the trick to this is to make sure they're oriented the correct way. And I have this terrible footprint that I forgot to change yet again on the silk screen that makes no indication as to which way is which. So this is why we have KiCAD up, is so that I can come in here and see that they are oriented down, facing down, all of them. So I'm going to be using the magnifier to do this, excuse me, for the most part, because it's kind of hard to see these things otherwise. Okay, down is going to be on my left. I mean the cathode mark is going to be on my left. So I'm going to orient the board this direction so that left is down. And I've gone through lots of different ways of doing this. The best way I've found is to try to pull them out of this package with the tweezers directly. Doesn't always work right, but if you don't do that, then you're chasing it around all over the desk trying to figure out which was which. Tweezers have some residue on them, and we gotta get that off. Actually, that might work pretty well. Okay, turn the board upside down because it seems that if I grab them out, let's see if I can get this where you can see it here. I grab them out with one end. It's not playing nice anyway. My camera's lagging really bad. So I'm picking them up end to end with like the tweezers on either pin. It's not normally the way I pick them up. Normally I pick them up side to side, but I can't get my tweezers into this packaging like I can normally. This is a different brand that I got. Should still work the same, but just about any diode will work for this purpose. position here. So yeah, I see somebody just hopped on. If you have any questions, feel free to drop those in the chat, and I will do my best to answer them. Honestly, there's not many people viewing because I didn't do a very good job of advertising. Nor did I do a good job of advertising the fact that it was delayed at night. So it's kind of amazing and, I don't know, disheartening at the same time to watch a pick and place machine do this automatically. It would have been done with like 10 boards by now. So one thing when you're laying out the PCB that I may not have mentioned before is that it is a very good idea, because of what you're seeing right here, to ensure that all the diodes are facing the same direction. Might not seem obvious. Might seem like a good idea to, switch them up to make the layout easier to do or whatever, but if you don't have them all the same direction, you're in a world of hurt when it comes to populating the board. And it is a little bit slower on the pick and place machine. Not marginally. It has to spin them all around. Shouldn't take that much difference in time. But then when somebody's inspecting the board to make sure that every diode is facing the right direction, or if you're troubleshooting it, all that sort of stuff, consistency. It's all about consistency. Okay. Alright, that is all of the diodes. Now on to the parts that don't take quite as long. That goes on top. Okay, gotta figure out what I did with all the parts. Okay, I have here the microcontroller. You see that there? It's really small. I don't know if it'll focus. That delay is killing me. Okay, now, got to make sure the microcontroller is oriented properly, because I have made this mistake before. I'm going to flip my board view in KiCAD. View, flip board view. So that it matches what I'm looking at on the table. See, the pin 1 should be at the top right. Pin 1 is indicated by, wait, how is pin 1 at the top right if it's supposed to be at the top left? Oh, okay. So that means it's rotated 9 degrees. Again, these tweezers have a nice sticky flux or something on them. Just cleaning them with this paper towel that has alcohol in it. Trying to make them not sticky. So that when I pick up this chip, I can set it down. Actually let go of it. I didn't get it all off. I'm going to spin this around, put it right in front of me and check it, make sure it's aligned. Because this is a very fine pitched QFN package that don't want to have bridges and pins that aren't aligned properly and all that. Okay, looks close enough. Alright, now what do we got left? We have the resonator, a few capacitors around here. We've got the LEDs, and we got the USB port. So I'm going to put things on mute here while I dig around and find what I'm looking for. Of course, this is the best way to keep all your components is in a big, box with just bags everywhere, right? Okay. Got 10 kilo ohm resistors, which we're going to need for the pull up on the reset switch and the pull down on the power on the there's a reset line on the PCB. All right, we've got a micro USB, mini USB port. Normally I would put USB-C on a new board, but since I'm assembling them by hand, I didn't really want to do that. I do have a new USB-C that is easy to assemble by hand because it only has one row of pins, but I hadn't used it yet. I just got them in along with this shipment of PCBs, so I wanted to make sure that I had something that was going to work for this. Those are really tiny. I have a bunch of 0402 parts in here that from some previous builds that are just really not fun to work with. Alright, there's 1/10 of a microfarad. There is a resonator I'm going to need here in a minute. 1 microfarad. 22 ohm for the USB termination resistors. And I think that's all I need. And then the last thing is just going to be those LEDs, if I can find them. Figure out what I did with them. I had them out yesterday when I was getting ready for this stream last night. And then, you know, clean up. Here's the case from the other day. Another PCB sitting in it. It does fit rather nicely. Haven't quite finished everything off. There they are. Okay. LEDs. I'll put those on next. I need 8 of them. I'm not the best tool for cutting up. Don't want to put this stuff on top of my PCB. Knock the diodes loose, which I just did. Missing 2 diodes that I knocked off. Well, that's what I get for throwing stuff over there. Got a whole bunch of loose ones from other projects. See, those I could easily just stick it in. I knocked another one off. Oh, never mind, I found them. They didn't get knocked far. Okay. I've got this ceramic resonator, which is slightly different part than a crystal, but it serves the same function. Provides the source for the clock on the microcontroller. Drop that in right there. Okay. The rest of these back in the bag so I don't lose them. Alright, I promised LEDs. Okay, so found that flush cutters are about the best thing for separating these, for cutting these reels. 8 of these, because you can get them right in there and they just make one nice clean cut. As opposed to scissors, if you get them slightly off, then you might accidentally cut through and dump the next part out. So I like to use flush cutters. Okay. These I'll typically just dump all out on the mat here and then pick up one at a time. So they have a little notch on one of the corners, and that indicates which corner is which. So you do only have a specific orientation, and I've got a corresponding notch on my silk screen on the PCB. The thing is sticking so bad. Let me see if I can use these tweezers. These are just a little small. It's not going to work. Just going to get the sticky off. You can go through and orient these and kind of place them next to where they need to go in the proper orientation. And it'll be a lot easier. Just go drop them all on one at a time. Okay. Those all align properly. Now onto the small stuff. Okay, we put two, like I said, 222 ohm resistors go on the USB data lines. Chop 2 of these out. Then I'm going to have USB port. later. One microfarad capacitors. I need a couple of these on the PCB, and then a couple of these here, and then most of them are going to be next to the. Actually, no, I think I only need a couple of these total. Yeah, that's that one. Most of them are going to be the 10th. So I need 2 of these capacitors. 2 of the 10K resistors. I'm going to go ahead and put these resistors and capacitors on so I don't get them mixed up with the other ones. I'll come back. Again, I'll just stuff them out here on the mat, pick them up individually. Just trying to very carefully take the plastic off without making the components go flying. 0603 are pretty small, but they're not terrible to work with like 0402. I do not want to do a board with 0402 by hand again. Okay, do these 2 10K resistors, and then everything else will be an 060. Will be a 10th of microfarad capacitor. There's going to be 1 per RGB LED, so that's going to be 8, and then there should be 1 on each corner of the microcontroller, so 12 total. Okay, finally we're going to get 12 of these little guys out. 22 minutes left until the stream is officially supposed to end. There's a pretty good chance I might get this done. So again, one of these per RGB LED. Four of them right around the controller here. And a USB port, and we're done. Not that anybody's actually watching, but maybe you watch it later. This has little pins that slide into the PCB, which make sure we get it aligned properly. Except that is not going in there. There we go. Oh, one more part that I almost forgot about. That is the speaker. Question is, where did I put it? Because they did appear to be in that box that I had down earlier. Well, I'll probably have to come back and put those on later. Look real And we're back. Found them. Okay. So this is just a little piezo buzzer. Make a real simple speaker circuit. Makes those little chip tunes like you have on some of the PCBs. Nothing special, but okay, I'm just going to give it a quick once over, make sure everything appears to be aligned. Try to check the diode orientation if I can see it. A lot of those alignment problems will fix themselves. As it reflows, because the surface tension will float them into place, which is usually pretty fun to watch. Okay, now then, we're ready to do some solder reflowing. And I have this very technical piece of equipment for that. It's also known as a electric skillet. Grab a power cord for it here. Get it plugged up, ready to go. I mean, this is very, very highly technical equipment. Don't want to got to make sure we have only the top quality equipment here. So now a lot of people will modify these to do the controlled temperature, the appropriate heat up curves and all that stuff, but I've kind of found that so this solder paste melts at 278 degrees Fahrenheit. So I set this thing in here just about a little over 275, between 275 and 325. Let it heat up, kind of keep an eye on it. Seems to work pretty good. Got my tweezers here. I'll just keep an eye on this as it starts to get hot. We'll start to see the gray solder paste turn to silver, and that'll be the indication that it's starting to reflow. Once I see it all kind of do that, then it'll be good to go. One problem with this whole setup is that this skillet is curved toward the middle to allow the grease to flow over there, and so I do have to move these around and kind of make sure that they're reflowing evenly. I'll even kind of press them down in the middle because that'll pop back out later. Trying to make sure that all the components are getting properly heated. Starting to get some reflow over here around the edges. Getting a little smoke from the flux. I went ahead and turned the temperature down just a hair, make sure it doesn't get too hot. to see him reflow quite a bit. Just about everywhere. It looks like they're all, these sockets look like they've either pulled up a little or just didn't get pushed down right. Those in there. Looks like the controllers reflowed over here. All these components look good. Speaker kind of came off. Turn the heat back up. The element is kicked off, so they've kind of stopped reflowing. So I'm just going to kick it back on for a minute and let it heat up again. Just make sure everything's good. Looking pretty good. Okay. I think we're good. Turn it off. Let it cool down for a few minutes. Got a couple of stainless steel plates from another build over here. I'm going to set over here to help this cool down a little more quickly once I pull it off. But I got to let it cool here, because if I try to take it off from here, all that stuff that I just put on and got to the proper location is going to slide around while this solder's still hot. So I gotta let that solder cool down enough that it's going to be possible to work with it. Then we can transfer it over here. One of these had some bump-ons on it, so I'm just going to go stick some on the other one just to make them sit at the same height. Yeah, at this point it'd be a good time to have one of those little non-contact thermometer things with a little laser sight, but I don't have one, but that's alright. I'll go back and cut all this out of the video on demand because it's just dead airtime since there's nobody watching right now. Get ready to flash this thing. Let's open this thing up in QMK Toolbox. Still pretty warm, but I'm going to go ahead and try to get it off of there onto here without accidentally knocking anything loose, if there's anything still loose. Stuff's all kind of turned back, so I don't think anything's still loose. There we go. That's a little warm. Get it off of there and let it cool down pretty quick. I should get me like some cooling fans or something to cool that down faster. I'll look it over while it's cooling, make sure everything is still, make sure everything's good. Check the solder joints. There was one up here somewhere where I'd smudged the solder paste on the diode. Thought there was. Don't see any issues though. It's already cooled down a whole lot. Checking the QFN, see if there's any issues with it. Don't see any bridges. Obviously want to get this down below the operating temperature of the components before I plug it in. Probably only one component I'd move in terms of how tightly spaced they are, and that's this, you won't really be able to see it, but one little resistor is kind of close to a socket there. I'd probably move that on the next revision. And it's, I mean, I can move it over a teeny bit without any trouble at all, so not concerned about that. Alright, I think we're back down to reasonable temperature. Let's see what we got. Find a USB cable over here. That's always the trick. I've got one plugged in, but I've had some trouble with it today already, so I'm going to use a different one. Plug that in, and I should get DFU device connected in QMK Toolbox. Look at that. That was really nice. Slide this over here. Kind of give you an idea what I'm doing here. And then I'm going to make sure I change the controller. You can't see that. Slide it down here. Got the firmware loaded up. Don't worry about what this box says. That's only when you're downloading. That's kind of a, I'm going to have to work on this UI. And then I'm going to hit flash. Wrote it, popped up as a new keyboard. We're good to go. Now here's the cool part. Instead of having to use tweezers, I can just pop switches in order to test this. So I happen to have a bag of Hakko violets here. So we're going to pop over to keyboard tester. I'm going to change out the scene here so you can see this whole thing. So I'm going to do some modifications here. So stand by for 1 minute. There we go. Now you're seeing keyboard tester. And I'm getting an escape. So let's reset this. Let me grab the rest of my switches. Pop a couple more of them in here. Already getting inputs. Now, obviously these are not not PCB mount switches, so I wouldn't build a board this way, but in the meantime, until I get my plate, just for testing purposes, it's not a big deal to just pop them in here. You can watch me put switches in here at the bottom of my screen if you want. Okay, well that one didn't fire up, so that means if you look, I got LEDs lit up on the bottom too, so that's nice. They all seem to be working. Yep. Got one there at number 3, 4. Got a few of them that are starting to not work. Let's try a different row. Oh, it's because my focus is not in here. I was getting worried. Yeah, every switch has worked so far. Pin got a little crooked. Obviously, like I said, I would prefer to have a plate, but for testing purposes, to make sure this is functional, not required. I kind of like these Hakko violets. This is the first time I've used them on anything. They seem to be nice. I like the feel of them. I just got them in today. Get a nice feel, nice and light. I've used the Hakko Trues, I think they are. Yeah, Hakko Trues. I've got those on a plank board that I've used as my mobile board for a little while. It's always kind of refreshing when I come back. This main board I have that I'm using right now has box browns. It's just kind of refreshing to have that lighter key when I come back to it. So I'm really excited to get a board built with these violets, because they've got a nice lightweight. I think with the lighter weight, the bump's a little more pronounced than it is on the. Honestly, don't know if these are a lighter weight version of the Trues or the Clears, but I'd have to go look it up. But in either case, neither of those have a very heavy bump. yeah, excited to have a board of these. Obviously I'll need to put stabilizers on when I get a plate. I can put those on, well, put them on before I put the plate on, but that is the nice thing about hot swaps, is that I don't have to worry about changing these out. It's as easy as changing out keycaps. I don't think the clicky noise from Keyboard Tester is showing up in the stream, but it is clicking. That's why I'm not looking up. My video blocking the bottom of Keyboard Tester, so you can't see what's going on there. Uh-oh, we got a dead one. Nope, I just lost my focus again. Yeah, see? That's what happens when I try to show you what I'm doing here. Some water. Here's the one that's not going to make a click because I programmed this to be, this is the split space. I programmed this to be a function key, so it's not going to make any noise, and I don't actually have the function layer defined, so I can't test it, but interesting. Keys are going wild. I'm not sure what mode I put that in, but oh, I may have the code in there where every time you hit a key it changes modes. I have that code on some of my boards, and I copied this from another one. Again, function key. That's a number 8. It's supposed to be a left alt. That's interesting. I mean a left, that's a control. It's not supposed to be. Let's win. That's doing volume. Okay, I'm getting some weird output. It's giving me shift. This one's not giving me anything. It was a minute ago. Seems like something got stuck down. Let's reset the board. See what happens. Maybe something just shorted out on me. That's Shift Z X C V B M. Oh, I bet QMK freaked out because I told it to go to another layer that I didn't actually have defined. Yeah, everything seems fine. I'm not going to hit these two buttons because they go to the other layers that aren't actually defined. Okay, yeah, we're all good. Ta-da! There you have it. Here we are, into week 4. We have functional keyboard. We have functional case. Almost. I realized after the show last week that I forgot to drill the holes in this, so I've got to go back and do that. But it does fit in here. Those switches do not stay in without PCB mount pins, by the way, so that's a good lesson to learn. Don't try to do this without a plate, oops, and without PCB mount pins. Just to show you that this does, in fact, work. It needs the spacers to fit quite right, but ta-da! Got acrylic plates, should be here for the switch plate and the top plate. As soon as I get that info over to Jordy. I do need to solder on that reset switch so that I can reprogram this. Obviously this particular case is not going to necessarily show off the RGB very well. Unless I maybe put transparent acrylic on top, you'll get some shine through. There you have it. Week 4, functional PCB in a almost finished case. So next week, just put it all together. Thanks for watching.